and welcome back to the Tyre Recycling Podcast. Welcome to episode 31 in our podcast series. We're now really racking up these episodes. You'll also notice that today is the first episode with our brand new branding that you might have seen in the latest edition of the Tyre and Rubber Recycling magazine. And as always, Ewan Scott, the editor of Tyre and Rubber Recycling, is here to guide us through the episode. Ewan, how are you doing today? And also, could you give us an insight into what we have planned for today's episode?
Yeah, we're doing fine here. Now, today's episode, we're taking a bit of a change of direction. We're at a couple of uses for Tyre Derived Aggregate with Andreas Petterssen from Vida Tech. Vida Tech's a German company. Andreas is based in Sweden. It's a step away from the pyrolysis, devulcanization, the usual sort of topics. So it'd be interesting to hear a bit more about this civil engineering company.
Is there anything specifically that you are looking to delve into? Because obviously, as you said, this is a topic we haven't touched on as much as compared to, devulc. Type pyrolysis, we've done a lot of interviews on rubberized asphalt. Is there anything particularly that you'll be looking to introduce our listeners and readers to?
I think the Greywater treatment is one element of the interview, but I think possibly the more interesting element is the use of Tyre-derived aggregate to create I think the best analogy would be a ground source heat pump, but this can heat and cool. So if you're in the north of Sweden, you put this in and it will heat your home. And if you're in Florida, you can use it to cool your home, to refrigerate your home. So that has potentially huge markets, especially with the ridiculous increases in the cost of gas and fossil fuels.
Yeah, absolutely. Okay, well, I think that's a good little introduction into what you're looking to gain from this conversation. So let's press the play button on that interview with Andreas Petterssen. So, hi, Andreas Petterssen. Can you tell us a bit about Vida Technology and what the company does?
Well, our company is one of Sweden's upcyclers for TDA, Tyre Derived Aggregates. We have been around since 2019 in this firm, but I've been working much longer with TDA in septic systems and as an aggregate for reuse for the 3 R's, so to speak. And we have developing more and more applications and trying to get this more and more out to the public, to the civil engineers, to make it more acceptable to use as a construction material. This is something that we have seen is there are more people than us that want it, but it is a very conservative branch of knowledge that you have to fight with when you're dealing with construction engineers and people with diggers and everything. They are used to dirt, soil, and so on. But we have constructed some very special applications that are more in the line of different kind of civil engineering areas, and that is something that we are very proud of, especially our 2 latest inventions.
So tell us about the 2 latest projects. I believe one of them is a Greywater purification.
Yes, we have developed a Greywater purification unit, which also has energy harvesting in it. This is something that we have a very large project up in the north here in Sweden, together with the Department of Energy and the Environmental Protection Agency, together with the different kind of house builders and specialty consultants. We have now 184 different what do you say? But it's a large house complex with 184 apartments. Yes, and they have now separated the gray water from the black water, and the gray water is going to go down to our GWHX, which stands for gray water heat exchanger. When the gray water comes down to our unit, it first goes down through a stainless steel basket that separates the largest particles and hair and things that are in gray water, and lets the gray water go down through, seep down through the TDA. We let the seeping, it goes so slowly, and we always have a buffer volume that we work with. That means that we can also harvest a lot of energy from this unit and send it back into the apartments. So what we have made and what we're about to install is these. This is 2 units that will represent a 85% of total recovery of the energy from gray water. And that is a lot in a housing. So we are actually at this point one of Swedish most has the highest recovery of energy from gray water at this time. That is something that's very special.
So you have a bit of a double-headed a project. You're recycling rubber and you're using it to clean grey water,
Yes.
and you're also extracting energy from that through heat exchange.
Yes.
And that's going back into the housing project.
Yes.
Yeah. Okay. That sounds an intriguing and a different approach to the market. At this time, with energy prices soaring, we need to be looking at projects that take a different view, a different route to not just recycling but generating energy. So that's a good news project.
Yeah, we think that since we have worked with all these different kind of agencies to make this a construction product, that also meant that we had to make a end of waste productification process, which meant a special kind of washing method. This also opened up for us to use this in water cleaning certificated areas. And together with a friend of ours that are an energy specialist, we have been tinkering for very many years about even before Vida. So we did these 2 things, and it is now patent pending.
Okay, so that's the first project you want to talk about. Now, what's the second project?
Yes, the second project is what we think is even more intriguing, because we have made a thermal energy storage, or exactly to be specific, it's a PCM LTES. That's a phase changing material that's latent for thermal energy storage. That means that we can store both cold and heat inside of our thermal energy storage. As it is now, when you need heat or cold, you either have to drill a borehole, or you have to buy very large tanks and install them, and you have to secure them or find different ways to handle this. But it's very seldom that you can have both heat and cold in the same. And what we have done and tested quite thoroughly also is that we constructed this energy mass of the Tyre Derived Aggregates, or the CLR as we call them. It's cross-linked rubber. Together in this, we put the TDA CLR in a bladder that are sealed together with different components and hoses and stuff. Yes, so we have a cost from $150 to $200 per 65 kilowatt hours, or if you take it down to the energy guys, we're speaking about $2 installed kilowatt hours. This is very, very cheap. This is like 1/4, 1/5, 20% of what the ordinary things are. And the good thing is with this is that you don't need a permit to have this, and you can have it underneath your house if you want to. You can store 65, 67 kilowatt hours of heat, but you can store even more in cold, as up to 75 kilowatt hours. So as an example, we made a package for of what we call the Florida package. They are always in constant need of cooling, and but they still want some heat, maybe eventually if there's really cold down to like 10 Celsius or something like that. And we took 15 cubic meters of the energy mass, a heat pump that was 5 kilowatt hours of how much it takes for operations. We put in 10 photovoltaic thermal solar panels, and together with all of these things, it was a cost for customers, except for the labor, that is around $25,000. But the thing is that when you in the night or in the day, you have first you have the heat, the solar panels, they deliver the electrical. You get the electrical. They take and see to that the power is covered for the heat pump and for the air tempers that deliver the cold. They put down heat in the energy mass that in the night the heat pump sucks up the heat and it evaporates it into towards the sky, and you get a cold, nice brine and liquid that's going down into the energy mass to be used next day. And as long as you have a delta T for 3 degrees up to 10 degrees, you will always have nice cool weather inside for a very, very low amount of money. And when you're installing the energy mass, you're not affecting the groundwater. You are not affecting any any animals. You have no possibilities of let's say people think about pollutants, or you have too much warm water going out or back and forth and everything like that. You have nothing of that. And the expansion that are made inside of the this invention, this is the real good thing, because the Tyre Derived Aggregate is the perfect media for this, because the rubber inside in the TDA takes up the force of the expansion from the cooling and the freezing. That means that this bladder where you have your TDA and you have compacted it, so even if you have it underneath your house, you don't have any swellings, ice swellings. I don't know what you call it in English.
Yeah, we don't get it cold enough. So yeah, you get the expansion and contraction from the frozen material. Yeah,
Yeah.
I have come across a similar technology where they used, and I think you also do it, Tyre Derived Aggregate as a backfill for foundations and so on.
Yeah, we've done lots of those.
And that in Alberta, in Canada, it withstands the frost in the winter much better than conventional aggregate does. So
Yes.
yeah. So this project, just so I've got it straight in my head, you would have a reservoir of a rubber chip buried in the ground, connected to the solar system.
Yes.
And the solar system would generate the heat to heat or cool the system. And once it's installed and up and running, you don't have you have no additional you've no heavy additional energy cost. It's self-contained. Yeah.
Yes. And that's also one of the good things about this is first of all, there's no moving parts. If we take the technical side, the other thing is that if you go with the thermal thermal injection from the solar panels, you will reduce your housing costs for heating and warm water all the way up to 95%. So
that's a massive difference. I mean, here in the UK, I have an average sized house. My electricity bills this year will have gone up by just short of 100%. So I think £1,800 they've gone up, which is a lot of money. And and most of that is in heat. So if I can reduce my heating bill with a system like this, then it has a positive, because you're competing with many other projects, air source, ground source, heat pumps.
Yes, yeah, and the thing is that we are not competitors in that way. We have tried to see and use the other things, positive things. So say like for heat pumps, you can connect this system too. If you even have a water heat pump for borehole or something, you can connect it straight away in, no problem. There is no competition there. If you have a air to water pump, you can connect it there also, and there it's actually a massive cost reduction, because instead of just sending it back and forth from the outdoor heater and the outdoor unit and the indoor unit, you do a bypass through the energy mass, and then you store all the good things down there. So instead of having the outdoor unit going so much intermittent, you can see to that you actually have a buffer for heating, and that is also something that we have that we have tried.
Okay.
So that is it's very versatile. You can use it in so many ways, and we have all the key figures, and it has been tested and so on. And I'm not sure if do you have the saying of the shoemaker and his kids? Do you know about that?
Yeah.
Yeah. So I'm actually going this year. I'm going to install one of these ones at my house. So it's not going to be
right. So that shows confidence in the product. Yeah. Okay. So what markets are you looking at for this project?
Well, we realized quite early that we as a firm are too small to bring this out wide and heavy and everything. So what we're looking at is to find some partner or some partners in first of all where usually people they see fit about where to put this in, because there are like say I have relatives in Florida and New York, and therefore it's easy for me to see the conditions that they have, and that's also why we made this Florida package. But let's say for colder countries or anyone else, it's better for us to do a licensing and see to that the technology actually gets out there. This is a technology that doesn't affect people or gets people interested in that way that they sometimes are when there are TDA involved, because we have learned that if you say all the things that TDA can do, they are very excited, and then they're like, okay, so what's it made of? Well, it's made of cross-linked rubber. It's like, okay, so what is that? Well, it's all tires. And then you see that their whole spine goes up, and they're just like, well, I have to think about this. And this is not a product that sends those kind of things through people. What's what we have seen. So we have bigger projects ongoing, and the key things with this is that even if you put it into the soil or ground, there is nothing that are in contact with people, not in contact with animals. It's not in contact with water. It's not in contact with any soil or something like that. So it's a very closed capsule, easy maintained thing.
Okay. So
and therefore it also builds acceptance within the other people to get to the other parts of the civil engineering where we want to go.
Yeah, so you have an encapsulated system, right, that is buried in the ground. So you have no issues with leachates, chemical leakages or anything. Now, you mentioned that it didn't need permitting. Does that apply just in Sweden?
Yeah, no, it's everywhere. The only permit that may occur is if when you buy this from someone, that it is still a waste that you have to report into the county or something more official, that you have bought a waste to install. But for companies that are making TDA, if they are selling one of the thermal energy storages, that is a product.
And yeah, so you have end of waste. Yeah.
Yes. So you have also with the end of waste, you have also bypassed the reason for having a permit.
Right. Okay. So I'm thinking in UK terms that there will still probably be construction permits required, but if it doesn't involve the Environment Agency, then that should be easier.
Yes, because this is also something that is of necessity as we see it more in the future. You have to store every bit of energy that you can get a hold of. If you're going to do this with a traditional costs, I'm not sure what boreholes cost there in UK, but here it's the equivalent, the same cost. But for installing one of the holes, you have to have the crawler and you have to drill and everything. You know, they come in, they do the stuff, and they go away. But if you're going to build a house, you have the digger there, and you order this, you can install this yourself.
Yeah. Okay. Yeah. So it's interesting, and I find that the tire recycling sector is very much focused on the tire industry and getting rubber back into tires, which is great. But we forget that by 2050, if the tyre industry achieves its aims of putting 50% recycled materials back into tyres, it still leaves the other 50% that need to be dealt with.
Yeah.
And it will be more than that, because some of the recyclates they're putting back into tyres don't come from tyres. Isoprenes and so on that come from plastics, styrenes that have been recycled. So we even if the tyre industry meets that target, that we still need good quality alternative recycling processes. So yeah. I'm very interested in what you're telling us here, and I hope that you do find the markets and the demand.
Well, it's catching up. We've been slightly paranoid as an inventor of these things. You know what they say: just because you're paranoid, that doesn't mean that there's not someone looking for you.
Yeah.
So but we've been very healthy and keeping things under wraps for a long time, and now when we know and we have tested things, we haven't told so many people, but we still have we're still calculating for 7 big projects just these 2 last months. And this is large housing projects from 20 apartments up to, I think the biggest one is 300 and something.
Wow, right. Okay.
So that's kind of cool. But I feel that if we're going to do this in that way, if we do the licensing, we can, because the technology is so easy. And I don't see any meaning of us. We can't go around and start companies everywhere and everything. I'm a certified inventor. I like to do things. I think things. I love that. I have education for running a company and everything. Harvard, but it's that's not where my heart is, and I still have this. I really love the TDA. That's a product that I've had for like 10 years of hardening and working with. We put in several septic systems. We have done floating foundations for large housings. We have done special day water runoffs with the walkway pavement was what do you call it? The water runs straight through.
Permeable.
Yes, permeable walkway, and for Amazon. So we have done and lots of more stuff, and it's all the people that works with it are very, very excited, and they like this. And but as for now, our factory is down for the moment because the electricity costs so much here.
Yeah.
And we have to be careful about where we put our efforts and money. And in that way, we have a slot where we can hook up with other people, because it's I'd rather see that other people can also make money, but make use of the TDA in a good way, because I also feel that this might sound harsh, but the environmental movement, the environmental movement that are, and as long as you say Tyre Derived Aggregate, they some people aren't really what do you call it? They are fact resistant.
Mm-hmm.
And this is a problem, especially here in Sweden. We have a very large movement, and you have to have every fact in place so you can show them at the same time as they ask, because if you don't have it, you don't have any time to do a second.
Yeah, so you get one shot.
Yeah, so we are very, very thorough with our things. The thermology, the storage, it's makes a lot of use. It cross connects different kind of. You can use it for real estate. You can use it for small housings. You can put it in yourself, but you can let large consultant firms with a real excavator operations firm and contractors put them in. But it's both high and low, but without the problem of the environmental impact that are under suspicion usually. Because when you say to guys that, well, this is enclosed, nothing goes in, nothing goes out. We have a couple of tubes that goes in and goes out. That's it. 0.0. So.
Excellent. Okay, so now I understand that you will be presenting at, or you hope to be presenting at the ETRA conference in Brussels at the end of May.
Oh, I'm well. If I could, we would love to. This is a joint baby with my better half, Åsa. But I think that this is such a revolutionary way to use TDA, and such a unique approach. And even though we are experienced TDA users, we have all the standard stuff in place. But this is such a new niche that are available for everyone that works with the TDA. So I think that this could be a great opportunity for everyone to both gain acceptance, to show the excellence of the TDA, and also make an environmental good impact, since there are it's like we've done all the LCA and LCC on these ones. So we have let's say that if you put this one in, you will have a minus of around 5 tons of CO2 that are bound into the 1 cubic meters of TDA. And you can use those inside of your lead or BREEAM calculation. So that would be super cool if we could present it, and I would love to. But if it gets out there, I'm still a happy camper.
So there you have it. That was our interview with Andreas Petterssen. Ewan, obviously, there were a lot of things going into there. What insights have you gained from that conversation with Andreas? As we touched on before, it's a slightly different topic area to what we've seen before in these podcasts.
I think the Greywater project is something that is pretty well advanced, and there are water treatment projects in Scandinavia and in Ireland and doubtless elsewhere that use this or a similar technique. The ground source, let's call it a reservoir, is interesting. It's more, I think it offers greater opportunities to take this into the building market. The company, they're dealing with house builders in Sweden, and they talk about a large, medium-sized housing estate being built, and every single home will have one of these fitted. And as natural as part of the build, it's the way it's described suggests that if you're putting a new property up, it can be added to the new property at minimal expense. And once it's installed, you've only really got the running costs of the pump itself. If you've got an existing property, you can have it installed in your front garden or your back garden, if presuming you have the space. He talked about Florida, and it was interesting that he talked about Florida because it gave us a chance to talk a little bit, I think perhaps offline, about connection with shredded tyre and Richard Spring, because he's in the construction industry and it's the sort of thing that he might be interested in. So I think they've got opportunities with that. I think there's a big market, and it's something that has benefits. The aggregate goes into a sealed bladder, and so there's no leachate issue. It's self-contained. It seems to me to tick all the boxes. It would be interesting to see where they are a couple of years down the line.
Yeah, for sure. But I'm sure we can revisit this with Andreas in a couple of years down the line and see the progression of the technology. Moving away from obviously what we've talked about today, and looking forward to episode 32, which we have already recorded at this point. What have you got in store for everyone in episode 32? In
episode 32, we're back speaking to Przemysław Saprozalski, who we previously spoke to about the Polish Tyre Recyclers Association. My apologies, I'm not going to try and pronounce that Polish. He is the R&D director of the Recycle Group. And as we will find out, the Recycle Group is probably the largest ambient recycler in Poland, and it is wholly dedicated to tyres. It doesn't deal with other waste streams at all. So we look forward to hearing what Przemysław has to tell us.
Definitely. Okay. Well, I'm looking forward to that. But that's all for this episode in the Tyre Recycling Podcast. Thanks, Ewan, for putting that interview together with Andreas. Thanks, everyone, to listening. And we'll be back very shortly with episode 32 of the Tyre Recycling Podcast. Until then, please stay safe.